see what we managed to find out about DNS. Because somehow our PC needs to know, if it's trying to retrieve web pages, it needs to know where it can retrieve them from. The way we talked about how to get to a certain website or how to download pages from a certain website was via a search engine. But you don't necessarily need to do that, do you? You can just open up your browser and go www dot and whatever domain name that you want. You don't always have to use a search engine. So if you know that domain, if you know the domain name you want, you have to have a way of finding where that domain is. So I'll ask somebody to start us off, but I want you to help each other out with defining for me what DNS is. So let me just pick on somebody. Connor, could you just perhaps start us off just to feedback? What is DNS? What does it stand for, first of all? Right, can you shout it out so everybody can? So everybody else shout out. What does DNS stand for then? Domain name system. Well, it's just so I want you to talk to me here. Right, the domain name system. So that's what it's actually called. What does the domain name system actually do? We use it every time we're on the internet, but how do we use it, Evan? We don't consciously use it, of course, but
yeah. When you type in the name of the website you're searching for, it sends it off to the server to some.
yeah, it is essentially. It's the way DNS works is by what we call DNS resolution. In other words, we say that we're looking for a certain website. Well, my PC currently doesn't know where that website can be found. So something has to act as an intermediary to find that website for us. What do we call that process of the DNS system finding a site? Can any of you gentlemen tell me that? It does convert it, but what's that process called?
Host name to address map.
It's what, sorry?
Host name to address map.
Yeah, but that whole process is called something. I'm going to confuse everybody in a minute because I'm going to use a word that I used earlier for a totally different purpose. What we call that process is DNS resolution. Only this has nothing to do at all with screen resolution or colour resolution or any other type of resolution. So we call that process of us requesting a domain and the DNS system finding which server that's based on, that is called resolution, DNS resolution. But how does it work? Josh, did you read anything about the sort of relationship between domains and IP addresses? Did you find that anywhere? Okay, Bonnie.
It stores records, it's a database of IP addresses.
That is the heart of it, yeah. Did anybody else come across that? Can anybody add anything to that? Well, so what we effectively do is if we've got a domain called www.spanishvax.es, there has to be an address stored with that domain, so that if anybody needs to find out where that domain is, they can find it. So let me just explain how this works. I'm going to go to my domain account, provided it will let me log into it. Yeah, the DNS system effectively is there for the purpose of providing an intermediate service between effectively my PC and the server, but it goes a lot further than that. So at the moment, I'm currently hosting about 60 domains on a server. And I've got a domain account with this company, 123reg.co.uk. I'm going to show you a DNS record so you can see how this works. or at least I will if this internet connection that we're currently experiencing speeds up. So what I'm going to do here, okay, so here I get a list of all the domains I'm currently hosting. I'm going to choose that one. And what it does within this interface, it gives me the ability, when it eventually loads up, it gives me the ability to manage this domain. So these are all the different things I can do with it. And one of those, look, is manage DNS. So if I click on Manage DNS, to Advanced DNS, this is the Advanced DNS editor. The thing is, if we're running a domain, we might want to run a number of different services on that domain. So I've got my own domain called ken-wake.co.uk. For that domain, I want email, I want web, I want web-based email. There are various services I want to run. So for each one of those services, I have to create a thing called an A record. And what the A record does is, at the moment, if I find one for say www, so that means when somebody wants to find my website on the World Wide Web, I have to create an A record which points to my server. So if I want to edit this, so let's just say I wanted to move my website from one server to another server, I would have to change that record to the new server's address. We're going to talk about IP addresses very shortly. So this is basically what a DNS record is. So every service I run, anybody that's trying to access that service in order to, say, forward email for me or whatever, they need to know about this mapping. So I've mapped an IP address to a certain service within my domain. And every single domain, you know, bbc.co.uk, amazon.co.uk, must have a record like this. You cannot work on the internet without DNS and a DNS record. Otherwise, nobody will be able to find you, even if they knew what website you're on. Because the DNS system controls the whole of the internet and the way it works.
If you knew the IP address, would you be able to get there if you have a DNS record?
No. Nominally you can, but the thing is you can't get an internet connection without DNS, you know, without active DNS connections. So it's really, it's like a fibre that runs around the whole of the internet. And without DNS connection or DNS resolution in place, you can't navigate anywhere, even if you know the address, the IP address. So that's what a DNS record is. So currently I'm running mail services, webmail, www, FTP services for transferring files, and then this one is a wildcard, and then those two are both mail server records. And then you just edit those to update them if you want to move servers. You can also, if you're using things like CNAME for instance, you can mess up your whole DNS and nobody will be able to find you. It is possible, unless you've worked with DNS before, to make a real mess of it. So if you're planning to run, you know, to ever get your own domain, it's a good idea to learn about DNS records as well before you actually start editing them. Because you really can create a horrendous mess. So it's not a good idea. Right, so let's just have a look at this in a bit more detail. So, our ISP provides a DNS resolution service for us. In other words, if I'm searching for that domain, www.spanishbanks.es, the first place I try and find DNS from is my ISP. In other words, my ISP is going to act as my primary DNS source. Because even though my PC's never visited that website before, somebody within my ISP's vast sort of range of customers may have visited that site before. And if they have visited that site before, there will be a DNS cache on this server which will contain the address of it. So in other words, the ISP then doesn't have to go searching for it itself. It's already got that information in the cache. Your own PC, as it visits websites, will also build up its own cache, which you'll probably have come across this when you go to start typing www, it auto-fills for you, or it may be that you've got it saved somewhere, but your PC creates its own cache of visited websites so that it can find them easily next time. The other thing it does, if you visit a site regularly, you won't have to download the whole site or the whole page every time. You'll only download the stuff that's been updated, because your cache already holds the images, keeps all, your PC saves all the images that were on it last time, and only if they've changed does it download a new one. You can just restore it from your PC rather than have to download it again. So subsequent visits to a website, if the website hasn't changed much, should be quicker nominally.
Is that for cookies?
No, it's just caching. It's purely that if you go through a system, if you go under the hood of a PC system, you'll find a folder called temporary internet files. Within that are all the images that you've downloaded and various other things that you've downloaded. Cookies are in there as well. So cookies are, every site you visit, that's got cookies, you will get cookies from it. But there is a separate cache as well in the browser itself. So this ISP will have its DNS cache. So when you send your search for, or you type the address www.spanishfacts, if it can find the IP address in this cache, it will then send the request direct to this server. If it can't find the address in that DNS cache, then we have to look up. In other words, we have to find where that record is held, and then get the details from that DNS record that I've just shown you. So each country, obviously we're UK. So does anybody read about where DNS records are kept, or who keeps these records? It should have been mentioned somewhere on the line. Sorry. There are records on the servers, but only as far as the DNS cache. It doesn't keep the actual DNS record, the full DNS record. It will keep a mapping of it, but it won't keep the full DNS record. Where is the actual DNS record held? Did anybody manage to read that? Was it mentioned on any of your research places? Yes, that's correct. Each country has its own domain registry. The one for the UK is a company called, did anybody get that far? Does anybody know the name of the UK registration body? No? It's Nominet. Every single domain that's registered with .uk on the end of it, regardless of what, whether it's AC.UK, whether it's co.uk, doesn't matter what it is, anything that's got UK on the end of it has to be registered with Nominet. There is no choice in this matter, none whatsoever. So anything that's got .uk, until it's registered with Nominet, it can't be used. So from my account, through my account that you just saw with 123reg, if I wanted to buy a new domain, I'll type, first of all, search for that domain to see if it's available. If it is available, I will then go to purchase that domain. 123reg actually take care of the purchase, but what they do is they confirm it's available by doing a live search for that domain. If that domain is available, they will sell it to me and then immediately register it with Nominet. And the initial record will show all the DNS for 123reg. In other words, as it's registered, 123reg will host it on their servers, therefore providing an IP address which can then be registered with Nominet. When I then go to use that domain, I have to update the DNS to point to whatever server I'm going to be using to host the site. So as you buy a domain, it has to have an IP address associated with it. So you have to provide that initial DNS information, and that then makes it available on the internet. It takes about 24 hours to register a domain and have it usable. So once you've bought that name, about 24 hours later, you can actually start using that domain. If you want to alter your DNS, if you want to update it so that your site is now on a new server, it can take 24 to 48 hours for that information to go all the way around the world. That's pretty marvellous if you ask me. You get that every single server in the world will know how to find your website within 24 hours. That's pretty good. So if we make a change to a DNS record, that information has to be relayed all around the net so that anybody can still find your website. Did anybody read what that process is called? That process of sending your DNS information around the net. You may not have got this far, or it may not have told you. It's called propagation. What do we normally associate with the word propagation? Yeah. Through growing stuff, you know, so through or distribution of seeds as well, and things like that. So if you think about propagation as, you know, sending all this information all out. And again, write this down because you will need to be remembering it. Propagation of DNS info. So if we update the details of the domain name, we have to propagate it around the internet so everybody can access that information. So propagation, that's what it's called. Okay, so let's just, I'm going to wipe this bit off. We're going to start looking at this process again. Right, so I'm sitting on my PC. I want to visit that website. I type www.whatever into my browser. My browser starts going to find that page. First place it checks is my ISP, but my ISP doesn't know where that site is because it's a brand new site, it's only been published today. Nobody in my ISP has ever heard of it. So what do? They look up. This process is called a DNS lookup. So they go direct to Nominet. And what Nominet says is that that particular website can be found on 184.39.7.4. That is the address you will find that website at. That information is then stored where? Yeah. That information, when we receive it, of the address of that particular domain, that will be stored in the DNS cache of that ISP. So the next person who's connected via that ISP who tries to find that site, they will already know. Obviously, it will check first to make sure it's changed, but then send them direct to the site. Remember as well that I'm saying that, you know, we requested this page, the ISP checks, doesn't know where to find it, checks with Nominet, gets the address back, puts it in the DNS cache, and then redirects your browser. That happens in milliseconds. You know, it's not a 10-minute process. This happens in milliseconds. You won't even know. In some cases, depending on the speed of your connection, you click browse, you know, to visit this site, and bang, instantaneously it's in your browser. All of that has happened before that page can be downloaded. So it's a fantastic system when you think about it. You know, the speed this operates at, even on slow connection, is still pretty wonderful. You know, because it's especially if you talk about .coms, because they're all American registrations. So the American registrar, you know, if you're looking at the .com address, you've got to go to the American registrar to find out. So, you know, it's a pretty, you know, pretty nifty system that we've got here, that you can tap in an address of a site you've never visited before, and about 5 seconds later it's in your browser. I mean, we call that slow, but it's pretty wonderful, really, isn't it? But so that's what's happening then. This DNS lookup is taking place, and we eventually establish that the address of that site is on 212.4.7.94, which just happens to be this server here. So our browser navigates its way, or the request from our browser navigates its way to that server, and that server says, right, you want the home page, we'll send that home page back directly to your PC. How does it know where to find it? So what's happened there then? We've requested the page, we've found out where it is, what server it's on, we've gone to the server, and the server has sent that page directly to us. It's because if that is the address that our PC is using, and I'm going to ask you in a second where we get that from, then that IP address will have been sent with this request. So you'll have an originating IP, in other words, ours, 16.4.39.7, and you'll have a destination IP. So the first one is your destination IP. That's the one we have to look up. This one. So the page is sent back to the originating IP, which is us. Now I'm sort of happily talking all here about IP addresses. We haven't actually established what an IP address is. So I'm sure you've all heard of IP addresses before anyway. What is an IP address? Greek, any of does that one happen? No? Sorry? Can't really define it. Okay, Maria? No? Nothing you've come across before, Shannon? No? Has anybody come across IPs before or been using it before? Okay, let me try them out, please. That's part of it, yeah. That's involved. Sorry? Yeah, I want to know what an IP address is. It's like the name of your where you're based on. Where do we get our IP? I mean, have I typed that IP? How have I got that IP address attached to my PC? Yes, it can be. There's two ways of getting it, but normally it is, yes, assigned. Who assigns it? Who gives us that IP?
Like ISP.
Yeah, ISP. Because we are part, when we join onto our ISP, we are part of a. It's not community, it's not, what is it? It's a vital word because it sums up the whole internet in one go. When we, sorry, network. When we sign on to our ISP, we become a part of the ISP's network. And the network, and the ISP is a part of a bigger network, which is a part of another network. Essentially, the internet is one huge network. A load of interconnected, every country is connected physically to every other country. If you're sitting instant messaging somebody in Canada, you are physically connected to that person one way or another. We're going to prove this in a second. So, without an IP address, we can't function. We can't have an internet presence without a unique IP address. You cannot have any two machines on the internet with the same IP address. Chaos, it can't work. Because if you've got more than one IP address the same, then if I sent a request to this server for a page, how would it know which IP address to send it back to if we've got multiple ones the same? It wouldn't. Your IP address is unique. There is nobody else on the internet with that same IP address. it can't be. That's one of the fundamentals of internet traffic. You cannot have two people with the same IP. So, where do you get your ISP from? Your internet address from? You get it from your ISP. How does that distribute? I mean, how does the IP address get from your ISP to your machine? Well, it's via this process, this connection process of cable, DSL, or dial-up. Does anybody use wireless internet on a laptop or on a phone? Do you ever get, when you start connecting, so let's just say you've got your own network at home, so you take your laptop away, so it disconnects obviously from your home network, you take your laptop back in again, and you might see a sign saying connecting to whatever network, obtaining IP address, and then it connects. That's what happens. Because if you're using a router internally at home, that will have a pool of IP addresses available for you. And the same thing happens with an ISP. If an ISP have got 1 million customers, they need 1 million IP addresses in order to be able to distribute to those customers.
So does it change the wireless network if you go back onto the network?
Yes, it can do. Depends who you're with. If you're with Virgin and you're using cable modem, it's unlikely your IP address will change very often. I've had the same IP for about 7 years now. But prior to that, well, if Virgin upgrade their network, then it's possible your IP might change. But I've been on the same one for years. But it depends who you connected with. If you're using dial-up or ADSL, each time you connect, you're given an address from the pool. Each time you disconnect, that IP address goes back into the pool. The next time you connect, you will get a different one. In the old days with AOL in particular, every time you browse to another page, you got a fresh IP address. It's a ridiculous system, but that's how it was. So, your ISP will have this pool of IP addresses. And each time somebody requests a connection, they distribute one IP address from this pool to a PC or laptop or phone, whatever. When you disconnect, that address goes back into the pool and somebody else will request it. There are some fixed IPs as well. You know, if you're, let's just say you wanted to run a web server of your own, or you wanted to run an intranet service or something like we do, so that our interact is available all the time to anybody. We'd work that on a fixed IP. So you can ask your ISP, can you please make sure I get the same IP every time? And what that's called is an exclusion. You know, they exclude that one from the IP pool and put it into another pool called pre-assign. And that works on Windows networks as well. Because if you're thinking about our internal college network, I need to ensure that that printer, for instance, has got a fixed IP so that it never changes. And because, you know, all the different PCs need to be able to print to that printer, so they need to know where to find it. And the only way we can find it is if it's got a fixed IP. So, that's one way of getting your IP address. That's called a dynamic IP. Because, you know,